So what's the bare minimum you need to do to have a modern web application up and running these days? Most of the time, you'd create a component, which is just a plain old JavaScript function, define some internal app state for the user data, maybe derive other values based on that state, and, finally, return some sort of template to be converted into DOM elements by a library. The expectation for this code is to be reactive, meaning that whenever the state changes, the associated DOM elements will be updated accordingly. Finally, you'd add your component in the document body, and you have an app running. Easy enough, right? Of course, there are slight variations to this approach, but when you really think about it, this is the core idea behind all modern UI libraries. So what if I told you that you can achieve all this with a lightweight framework called VanJS? How lightweight, you ask? Well, the whole framework is written in only 133 lines of code. Of course, there is only so much you can do with such a small codebase, but you'll still be surprised by the things VanJS is able to achieve. Due to the recent major improvements in both JavaScript runtime and the DOM API, big names in the industry are starting to argue against established bloated frameworks in favor of going back to plain old JavaScript instead. In this context, VanJS, weighing only 900 bytes gzipped, could be the perfect foundation for your next Vanilla.js project. Thanks to its ultra-light codebase, we can go through the entire VanJS implementation in just a couple of minutes, and this is a great chance for us to review how frameworks are actually working under the hood, what are some of the main problems they are solving, and what techniques and JavaScript features they employ during this process. Before diving into Van's implementation, we should briefly review 3 core JS concepts we'll be using throughout this video. The Proxy API allows developers to wrap objects in proxies, which can then intercept and redefine fundamental operations for that target object. Proxies are created with 2 parameters, the target original object and the handler object that defines which operations will be intercepted and how to redefine intercepted operations. This handler can contain traps for all object internal methods such as construct to capture an object constructor or set to capture property mutators. Next, prototypes are the mechanism by which JavaScript objects inherit features from one another. This is a rather complex topic, but again, let's focus only on the scenarios we'll need in this video. I'm defining a customer object which has a first name and a last name. We can access those properties just fine, but whenever I want to access a property called full name, we'll get an undefined. We could easily add this as a new property in the object, or if we know this logic might be reused in other objects as well, we can define a prototype object, define the property in there, and then simply assign this new object to the customer's special proto field. Whenever you are accessing the property of an object in JavaScript, if that property is not found, the engine will look into the objects up the prototype chain next. All objects will have at least one prototype, which is the object entity itself, and this one ends the chain with a proto value of null. The final concept I'd like to mention before jumping into the codebase is JavaScript's event loop. While JS is single-threaded, it's also non-blocking in nature due to its event loop. A bird's-eye view of the runtime looks like this. Any work that needs to be done is pushed into the callback queue. The event loop is always monitoring this queue, and whenever the stack is empty, tasks are moved to the stack where the execution of the code is performed. A trick to push code at the end of the queue and avoid blocking the UI thread with work that's not urgent is to pass the workload as a callback in a setTimeout function, and this is why you'll see bits like this in Van's codebase. Okay, let's look at the actual implementation next. On paper, any modern UI library has 2 main responsibilities. First, it needs to employ some sort of reactive mechanism to manage app data, and second, it needs some sort of templating mechanism that translates the reactive data into DOM nodes and updates. So let's look at the reactive state implementation in more detail. State is a function receiving an initial value and returning a wrapper object containing the value, a list of binding for the DOM elements depending on this state value, and a list of listeners where derived state objects can register to be notified about changes. The return object also has a special prototype where additional logic is performed where values are accessed or modified. Since all state objects will share the same prototype, it's also easy to figure out what values are actually state instances. In this prototype object, a list of dependencies is maintained when the value is accessed. This is used to keep track of the functions and DOM bindings using the state value. Then, in the setter implementation, whenever a value is updated, the derived listeners are notified, and then an update of the DOM elements is scheduled. State can also be derived. This is a function receiving another function as the first argument. An interesting implementation here is the run and capture dependencies method, where the past function is executed and its state dependencies are extracted. The nice little trick here is that when the function is executed, the prototype get value will be called and the access state will be pushed to the current dependencies array. Computing the dependencies is very important because whenever these dependencies will change, the deferred construct will be executed again. Let's move to templating next, where Van is offering a very simple but powerful solution. We can import any DOM element from the Van text property and then use this to compose the UI. Quick side note, JSX is probably the most popular templating solution in front-end development, but such an approach is out of the question here since Van focuses on simplicity. JSX is a syntax extension to JavaScript, and it requires a compilation step to convert the JSX tags into code that the browser can actually understand. Okay, back to Van, we were just importing some HTML tag elements. Van solves this implementation in a very elegant manner. Tags is actually a proxy which has a function as a target and a handler with a get trap. When we import elements from this proxy, the trap is taking charge and will return the target function and the property name the user is getting. This is how we can capture the button or h1 name and pass it to the resulting function. This name is then used to create a DOM element. The tag function can receive as the first argument a list of DOM properties, such as class names or event listeners. These properties are linked to the element and various adjustments are performed based on the property type. For state values, we need to make sure that the underlying value is used, and for function bindings, we need to make sure the function is actually executed. I am mentioning state and functions because these are reactive values which will trigger DOM updates. Once the attributes are bound, the last step is to update the DOM element children. And now we got to the final piece of the puzzle, the part of the implementation that makes changes in the state trigger DOM updates. We've seen how dependencies are extracted and pushed into state objects in the run and capture depths function. Also, when we looked at the state value setter, I mentioned that updates in the state will also be tracked in a change states array. All these are then used in the updates DOM function to reflect state changes in the DOM. If you are interested in other deep dives on various tech topics, please click the like and subscribe buttons. Until next time, thank you for watching.